Okay, let's go ahead and look at another point charge problem. These are the problems that we're focusing on, and the expectation is that we are maybe getting kind of good at these. So here's another one. We've got three charged particles, and I'm going to start here with part A, which asks us to find the electric field at point P. So let's analyze our situation, just the physical situation first, and get some information out of that. We know that in order to find the electric field at P, what we're interested in is the relationship of each charge to point P. So one of the distances that we're going to care about is the distance between C and P, which is that right in there, and we're going to care about that angle too. So right away, we can kind of have a look at that. I can label, it doesn't matter which angle, I'll label this one from the vertical just to do something a little different. Um, and then we need this distance here. This is going to be a root 20 in there. And I'm going to go ahead and figure out my sine and cosine of phi while I'm here, just so that I can refer to them later and they'll be done. So sine of phi, go ahead and look at your right triangle there. It's going to give you 4 over root 20. And cosine phi, 2 over root 20. Okay. Those could simplify a little more, but I'm just going to leave them as is. It's fine to leave them like that. We need a coordinate system, of course. So let's go ahead and go positive y upward and then positive x rightward. So that gives me, for my unit vectors, that gives me positive j hat upward and positive I hat to the right. And now I think I have everything set up, so I'm kind of ready to get started. So we're finding, again, we're working part A right now. We're finding the electric field at P. So what I want to do is, I know that this is going to be, the electric field at P is going to be the sum, right, of the vector sum of the three different electric fields from each particle there. And I know that the equation that I'm using, I'll do this in the upper right, is that of the electric field due to a point charge is equal to kq over r squared. That's my general equation right there. And I remember that that's magnitude. There's no hat on the E. So this equation just gives me the magnitude. The direction I have to figure out on my own from the diagram. So right away, I'm just going to draw in a diagram for electric field at P and draw in, remember this kind of vector diagram here, where I'm just going to pause and give some thought to what does this look like, right? What does this electric field look like? So if I look at point P here, I see that the electric field, I'm going to have a contribution from particle A, and particle A is a positively charged particle. So that is going to be outward, radially outward from the particle. So at the location of point P, that will be pointing down. So that's the contribution from particle A. Look at particle B. Particle B is negatively charged. So I'm imagining radially inward electric field lines there. And so at the location of P, that's actually going to be an upward vector, E sub B. And then I can look over at particle C, negative. So radially inward is what I'm picturing there. So at the location of P, I've got an EC that's going in toward that particle. So that's going to look like this. E sub C, here's my angle phi. Be sure to transfer those, however you label your angles, be sure and transfer them to your vector diagrams. They need to be there. Great, so I have this diagram, and now that just kind of helps me a little bit to think about what I'm doing as I'm writing out the equations. I'm writing out the equations that are going to represent what's going on in this diagram. So cool. The electric field at point P, I'll write this out then. Now vector form is going to be E sub C. Now slow down, check it out, sine of phi and that is going to be I hat. And now I think I just have all j hat stuff here. E sub b minus E sub a plus E sub c cosine phi. And that's j hat. So take that in. Okay, and then we can pop in our magnitudes and our sine and cosine. Let's slow down and just write each magnitude out, since maybe this is a little bit new to us. And we are using this equation right here. Yay, electric field due to a point charge. So that's our general equation. Okay, so to do that, I can figure these out one at a time. E sub a, again, this is at the location of P, right? Due to A is going to be K, magnitude of charge A, which is Q, drop the sign, over distance between this charge A, and the point of interest, and that distance is 3A, that'll be squared, so that's 9A squared. Electric field at P due to particle B, K, magnitude of particle B charge, which is 3Q, and then distance between B and point P is just A, so that gets squared in the denominator. Finally, C, magnitude of charge C is 5Q, distance is A root 20, that gets squared, so I end up with 20A squared. So those are my magnitudes, and I'll just go ahead and simplify this one. Very tempting. Cool. Then I can write out my final expression. So E sub c, that'll be KQ over 4A squared times sine of phi, which is 4 over root 20. That's all I had. E sub b, 3KQ over A squared minus E sub a, which is just KQ over 9A squared, plus E sub c, KQ over 4A squared, times cosine phi, 2 over root 20 j hat. So this is my final expression. Notice that it's in unit vector notation.